Okay, so from the graph, I think it's saying not grad. Okay, these are the percentage of graduates and then the one for not graduates. So the people with lesser income are mostly graduates, and what else? Like, let's just say between this 100 and, I mean, 10,000 and 2,000, they have more graduates, and then while it's increasing, there are fewer graduates who apply for loans. While on the not graduate side, we have fewer people who are not graduates, and they also have lesser income between 10,000 to 20,000. They also apply for loans.
So there was you made one statement, the first statement you made. I'm trying to remember it, but there's something about it that I wanted to kind of, is it correct also? Okay, I can't
Yes,
remember.
I think I already corrected it.
Okay.
Yes.
Yeah, thank you very much. Is any other person saying something else? Something different from what Ivan said, or something close to it? Is there any other person? Okay, then I will continue. Now, thank you very much, Emmanuel. So we could see here that yes, a lot of graduates, they have what's it called? A lot of graduates have high income. Because what I plotted on this particular graph is I want to test what is the implication or what is the correlation. Let me put it that way. What is the correlation between the income and then the education level? You understand? So let's see if it influences one another. And we can see from here the level of education determines the degree of what's it called, their pay or their income. That we have some of graduates that are collecting high income. You can see up here, there is no non-graduates that is reaching beyond, is it 20,000 now? But we have graduates that escape to that level. Even though we have some graduates that are still collecting something close to what a non-graduate is collecting. And we also see that.
Yes.
So there are some graduates that are on this level. So this is just a real life data telling real life story like that. So you can actually compare different things. I can choose to want to know. I don't know why this is loading. Okay, I may choose that I want to know. Where's my variable tab? Let me see your own. You can choose to say, okay, let's test married and those people that are applying. Do you understand? I want to know the if marriage has anything to do with loan application. Do we get the scenario?
Yes.
So is it that people that are married, they are always collecting loan? You understand? So that's what I'm trying to deduce. If I use married here as a column now, and then probably I'll change it to something else. Or let's compare married with loan amount. So let's see the amount of loan that people that are married collect. How does it differ from the amount of loan that single people or unmarried people collect? Let me see the type of values that are inside married column. So we know, okay, so married yes or no, right? So we know that those ones are yes, they are married, and the one for no, they are not married. So let's plot this particular graph and see. Okay, can we see it?
Yes.
So apparently, the amount of loan, you can see it's kind of, how will I put it now? Kind of close, but then still the married ones outnumbers those ones that are not married in the amount of
Yeah.
loan that they collect. So you can just tell them that way. That may explain the fact that married people have more responsibilities. Does that make sense? So I'm using their data
Yes. It does.
to tell a story to them. So an example is maybe in a real life store where they want to see the kind of they want to do another stock. So they want to know what to put in their supermarket. So they now give you the data set of the previous years, what they have sold, and the amount they have generated annually. So your own is to take the data set. Then maybe you pick a column in the data set, and then you saw the kind of thing they've been selling. So they show you that when they put chin chin beside cake, people always buy the two. You understand? That's telling a story, it's telling us something. So it's implying that there is correlation between chin chin and what's it called, and cake, or there's correlation between sander and clothes. So next time they are taking stocks, they know that okay, when we arrange this and store, we are going to put chin chin um beside cake. What have they done, or what have we helped them to achieve? Decision making. So that's just what generally data science is doing. Like it helps in decision making and all of that. So from here we are going to move on to another type of column that we have there. Now we have dealt with numeric value. So I would like you to do this for different ones, and then by yourself look at it and then try to interpret, see if there's any correlation, and try to kind of judge the implication of the correlation. Someone is saying something? Okay. Now I'm going to go to another. We did numeric distribution. Let's take another one. This one is called categorical distributions. What are categorical values? When they say something is categorical, and someone just briefly explain what that is. If you have come across it before, when they say a value is categorical, what do they mean? Or what does it mean for a value to be, everybody know what it means for a value to be numerical, but what does it mean for a value to be categorical?
The value falls into different categories.
Okay, makes sense. Any other person? Okay, so it's very correct. They have one or more categories. You understand? But then there is a kind of ordering to the categories. So, for example, if you have gender will have how many categories?
Gender has two categories.
Female and male.
Yeah.
So there's no specific, how will I put it down? It's not like it's leading to another. It's just kind of, if I'm permitted to say discrete, but then it's in categories, but then there's no kind of intrinsic ordering that is going on around there. So there is no particular order. It's just categorical. Example of the one that can have order is another data type already. I think that should be my we have categorical, which is the same thing as nominal. I'm trying to remember the name for the other one, but for that one,
Ordinal.
What do you say? Ordinal.
Ordinal.
Yeah, thank you very much. Thank you. So for ordinal, the way ordinal works is it's in categories too, but then there is an intrinsic ordering. So there is a way it's ordered. So for example, in a situation where I'm taking, let me see what I can use as example now.
Say level 1 or level 1, level 2, level 3.
Yeah, thank you. So you can see one level is kind of following another level. So there is ordering level 1, level 2, level 3. So that's basically different between a ordinal data or variable and then a categorical variable. So I just use that one to kind of explain what it is for us. Thank you, Evan. So let's deal with how do we see the distribution of a data type that is categorical? Because these two tools that we use here, the histogram and the box plot, they work well for numeric data or numeric columns. But categorical, how do we address that? So there are other ones, there are other kind of graph you can plot.
Wait, can I
Okay.
ask a question?
Yeah.
Yes, we did something with the box plots. That's like the color using two attributes, two columns, the loan
Yes.
amount by married. Is it possible to do the same thing with the histogram?
With the histogram,
Yes, I'm not sure if it's possible. I just want to
I'm not sure too, but maybe we should make attempt. I'm not sure. But then let me see. I'm not sure, but can you just kind of explore at your hand? Let's see.
I can't think. I'm just asking.
Yeah, I'm not
I
sure
can't.
too. So I've not really done anything in that line before.
No, okay, thank you, ma'am.
So I can't really give an accurate answer for that. So, but in case if I find out, then we are going to test it and see how it works. But I don't
All
know
right,
if
thank
it
you.
exists or not.
Thank you.
Yeah, you're welcome. So we're on categorical values or variables rather. So for this, what I'm going to do is this. I'm coming. So we are going to use bar plot here or bar chart here. So I'm going to get my frequency distribution and then put it in a variable.
Sorry,
Now,
please, what's the full meaning of this DF again?
data frame. And it's just a variable name actually. You can change it to anything. If you see here, I was the one that named it data frame.
Okay.
But I'm just giving it a name of what it's representing. You understand? So that
Yeah,
by the
like
time I come, I'm able to get that this is data frame and the class that is accessing is, of course, the data set, which is my data frame in quotes. So if you give it another name, maybe you call your own my data sets. Wherever it is that we have used DF, you are going to be using my data sets. You understand?
yes.
So let me assess which categorical column do we have in this our data sets. Can someone guess if there's any? Okay, maybe I should show where we have the data. Do we have any categorical, from the explanation we have given for categorical data, can we just glance through this data set table and see if there's any categorical data there?
Yes.
The area, education,
Gender, property area.
Education, property area. Where's property area? Okay, urban, rural. Which other one?
if
Employment
employed,
status, if employed.
Employment, if employed, yes. But we didn't notice this credit history too. 1 and 0, 1 and 0. What this is representing, because there are sometimes you just have to read the details of the data set that you downloaded. From that data set, I'm coming, let me share screen to that page again. They explained something there. They said the one is representing that the person have a credit history, and then the 0 is representing that they don't have credit history, but they only decide to store it in a binary format. You understand? So this is still categorical.
Okay.
Do we get?
Yes.
Yeah, so you've listed different ones that are categorical values. So which one should we use? Which one should we plot on our graph now? Which one should we plot? Maybe I should just pick credit.
Gender.
Okay, gender. So what this is going to give me is going to give me the value count or distribution. You understand? It's going to give me the frequency distribution, meaning how many gender, sorry, how many male, how many female. That is all this line is going to give to me. So this is what this value that this generates is what I'm going to use to plot my graph. And I just comment these guys out. Alrighty. Now let's run this. Let me see what is here. So you can see. Can we see what is showing us?
Yes.
So it's showing us that we have 112 female, and then we have 489 male, right?
Yes.
Okay, so that's our frequency distribution or value. So this detail is what I'm going to use in my bar chart to draw my bar chart. So to plot your chart, you are going to use this code. So just follow as I'm writing. I will explain the line I'm able to. Now you remember that here is where I will use my math plots. All the one I've been plotting the other time, I've not used my math plots directly. So PLT is representing what? Math plots. So I'm going to be accessing some methods inside matplot. So this is peak size. So I'm just specifying the size of the figure and stuff. Let's add underscore. So actually, a time will come when all I will be doing is I will have to put the code somewhere and then just be copying and paste. You understand? Because this typing can be a waste of time sometimes. So let me set. At this stage, I've already kind of declare my axis value and stuff. So now I want to set some details about the axis. So I'll say set x label. So what this one will do is to give it the label that I want to have on the x-axis. So this is having credit history. And then let me just copy this for y. And to see. And then this is y. So what should be on our y? Maybe y should just be okay. Someone wants to say something.
No, you can choose anything.
It's just number of. Basically, what is on y-axis is the way we have it in those other graphs that we did that time. It's just the distributions showing the numbers or the frequency rather. So frequency is more or less like number occurrence. So that's why I put number of applicants. Then another thing I can set here is to set the title of the graph. Title. So what should we give it as a title? Maybe I should just call this applicant credit history or credit history of the applicant. However way you want to name it, just put something that really defines, or if you are presenting this in a board meeting, they should be able to tell by seeing your diagram that this is what this is doing and all of that. Yeah. Let me see how this graph looks. Okay. Conditional argument follows keyword argument. What did I do wrong there?
I think the last line is supposed to be temp 1, or is it just temp?
Okay, yeah, this is supposed to be temp 1 too. So that error will still come up. But the first error is pointing out is here. So this, my value is supposed to be in a bracket. So like you said, this is supposed to be temp 1. Because that's the frequency that I clear there. Is this the frequency actually that is going to take and plot? So each plotting, all these ones I've declared is how I want the plotting to look and all of that, or the details that I want on the plot or on the chart. Okay, object is not callable. Which part? ELT, figure, fixed size. Comment. I'm just making a mistake. Let me confirm that. Comment please. Post, PLT, figure, then fixed size. So that's the right thing. So why is it not working? Am I missing something else? Come. Module. Object is not calling. Okay, wait. I don't know if. Oh yeah. I've imported. Okay, let me just introduce this first. If that's the issue, but I'm not sure. But I'm coming. Let me be specific about this. Yeah. So because I didn't specifically state what's it called, what part of this. Now, if you check, it's saying Matplotlib is a state-based interface to Matplotlib, like the MATLAB, like of plotting, and also this one, this is where this particular module that I'm trying to access is specifically in this PyPlot. So by the time when I didn't put PyPlot, it didn't run. It was just bringing error, the previous error that we saw. But then now it's working fine. And then let's preview what we have plotted. Then we'll go to plots. Okay, so I need another person to interpret what is going on to us. So let's assume you're the one that got this. So while you are interpreting, I'm typing the next line of code because I'm trying to watch time. So someone should be interpreting what is going on there for us.
I think it just shows a lot of males have been applying for loans over the years compared to the females.
Thank you very much. So what in real life, because each interpretation you make, it's real life data they gave you. So they want you to also give real life interpretation. So you have given a statistical interpretation or related to real life. What does that give us any hints on why will more male be getting loans than female?
Because they need more money to take care of more responsibilities. So they tend to collect more loans than females to get taken care of.
Okay. So that obviously, considering the society and how the standard, the responsibility of the two gender, we know that this particular output is not out of ordinary. So it's something we should expect, just like Emmanuel. So thank you, Annie. Thank you, Emmanuel. Hi, Emmanuel.
That's Emmanuel.
That's Emmanuel. Sorry. Okay. So that's
Sorry, I'm having an error.
Okay, what's your error? Can you share your screen?
Telling me. Okay.
Let me stop sharing mine.
So hold on, it's like I found the. Yeah, I found it. Sorry, it was just one closing bracket I omitted. Thank you.
I'm glad you were able to debug it yourself. So that's just one should not be afraid of having errors because it's not very interesting because you are able to know more functionality of whatever module or library that you are using. By the time I imported this, by the time I was trying to use this the other time, it was telling me, it was stating something, then I have to figure out, is it that I'm not importing the library well? I realized that the library I actually imported, I didn't specifically state the one that affects this thing that I'm trying to call here. So it's cool to have error and then to debug it. Now there is something.
I'd like to also ask a question.
All right.
Can you do well to just explain line 40 to 46?
Line 40 to 46. Okay.
Yeah.
So now what line 40 is doing is that like I think I've explained line 40 before. I said it's gathering the frequency, you understand, of the data set, of the column rather. And when I display it here, where is it? Which is step, it showed us that these are the number of, this is the frequency we have for female, this is the frequency we have for male. So what he does was to store this frequency. What it does was to store this frequency in this variable that I declared here.
Mm.
So by the time you store it here, then all this from here to here is trying to how will I put it now? Generate the real chart itself. Now for this one goes to the library that we declared that time, and then access figure. By the time I click on figure, we can see what figure is actually doing. Figure is taking you can see the parameters that is taking. Norm, fixed size. The fixed size is specifying, I think it's specifying the dimension of the graph. Understand? So it's specifying the dimension, like the width or the height of the graph. Are you getting it, Ayobami? Hello?
I'm with you.
Okay, so it's trying to tell us, we are specifying here that the figure we want to extract or we want to draw from this matplots, pyplot library is a figure that has the size of 8 by 4, like talking about the width and the height. So, are you getting it? So we store this inside pig. You understand? So at this stage in the program, this pig already has something inside it. And what it has inside it is a figure that has that particular structure or dimension that we just stated. I don't know if we click here, I don't know if it's going to show any image, but let's try. Okay, so it's just showing it in form of like the data and all of that. It's not showing it in image format yet.
Oh.
But then this is what this part is doing. You understand?
Okay. Yes.
Yeah. So then we move on to now start specifying details about the axes and how. So we're trying to specify this. We said the figure, this particular figure that we have inputted, that we should add a subplot to it. Now this 121 specifically, I don't know what we're going to do, but let's see. Let's over on it and see. It's saying this 121 is x. Second one, if x is not a number or if it's base, then x must be exchanged by it and all of that. No, given if x. Okay, I don't think this is explaining well what this is supposed to be doing. But I don't know what this figure is. But I will probably guess I will be saying something like, well, I don't think I will have a perfect guess. But what this is doing is to add a subplot to this.
Does that mean we can use any figure?
Should we try? I think we can just explore that together. Let me put 200 and see if, so at least we'll be able to deduce if it's doing anything. Okay, number of columns must be positive, not 0. Which side is down or coming from?
200.
Wow, must be positive, not 0. Number of columns must be a positive, not n columns. Okay. So from there, okay, let me change it to 121, 122. Okay. So I'm trying to see from that error that it brought, what I'm trying to deduce here is it's talking about the number of columns, or when we plot this graph, it's kind of, how will I put it now? I'm trying to see a better way to explain that. But what this is exactly doing is talking about number of columns. And when I put 200, it's already outnumbers. Okay. None must be 1 less than or equal to none, less than 10, not 5. Rows by column, not none.
I think there are 3 different figures for 3 different axes
Oh,
for the rows and columns.
thank you, Emmanuel. Thank you. So by the time I put zeros, okay, let's run this again and see that error.
0 won't run.
Okay. No, I wanted to see the same error it brought the other time. So it's
Okay,
saying
okay.
number of columns must be positive, not n columns. Number of columns must be positive, not 0. So I think it's referring to when I put this 0, 0, like that. So the other times, okay, I think
How many
let's
is
try another
211?
value. Okay, let's
Yes,
see 1.
211.
Yeah. Okay. So these are actually
I think
each
it's
of
counting
these.
because it's counting from 0. So when you put an even number, according to it, that's like, because it comes from 0, 200 now it will be 201. If you put 211, so it will add the 0 and then it will be 212. So it's a positive. That's what I'm thinking.
Okay. But then the way I'm seeing it is as though I wanted to go back to one particular error I saw, because this is talking about rows and columns.
Rows and columns, yes.
Specifying dimension now. So when we changed it to 120.
Can we see with this 211? Can it? Oh, sorry.
Okay, I think we used 211 before, eh?
I wanted to see the size of the plot of the bar chart.
Okay, for the 211. Okay, I'm coming. So rows by columns. Okay. I'm trying to get the value that are here.
What if you change the 8 and 4? And let me see, you put an odd number there, like 7 and 3
I should put
on the
what?
field. On the row and column, we've said the size is 8 and 4. So we put 7 and 3 and put 200 and see what happens.
Okay, I put 200 that time and it brought error. It was telling us that.
No, and here on the 8 and 4, put. Yeah.
You should change the fig size.
Okay, I'm coming. Let's test this and see what this runs for. Then I'll now change the one ending is same, because I think it's going to have different implications. Can we see the implication of this one? It's kind of expanded the width and then
Yes.
Yeah.
Yes, I think it
reduce the height. So it's kind of
has
talking
to
about
do with
dimension. What is it? Who said something? This different one that this was the initial.
this 1-to-1.
This should be this
I think
is
it has to do with ratio, because there's something changing. The ratio scale up is even changing.
the what?
Your voice is not clear.
Yeah, it wasn't clear. Okay, so I think should we return this back to what it was?
Yes.
2, 1. So we saw when this one was 2. I think the first value affected. Okay.
Yes.
Manu is trying to say something, but we can't hear you clearly. Your audio is not clear.
Wow.
Let me just run it again with 1-to-1 and see what happens.
Yeah.
I see. Okay.
So the when this was 2, this was very large. So this represents the width. The way I'm saying it, this represents the width. This represents the height. And then this other one is, is it in mathematics or what course or subject is that when you have dimensions, that sometimes it's 3 values.
Yes, it's in vector mechanism. That's where it is. X, Y, and Z values.
Yes, X, Y, and Z values. Yes, so that is exactly what this is. The X, Y, and Z value of the graph. So when you run it on your system, try and adjust and see different things. So let's change this as any said the other time. So any you said we should change this to what?
7 and 3, we see what happens.
7 and 3. Okay. Do we
How
notice?
has changed?
Yeah, it's kind of changed. Please, this network will soon go up like in 1 minute again. Let's quickly reconnect back. Sorry for that. So now
Okay, so
there is a
sorry,
change.
let me just say something.
Okay.
The 1-2-1 guy, I think the first one is for the x-axis, the second one is for the
Y.
I think it's like a ratio. So I changed the
Yes.
2 to 4, and then it became taller. So when we changed the first 1 to 2,
It became wider. Yes.
So I think it's a kind of a ratio thing. But the last one, I don't know what that is. So maybe
The last one, like we said, is the Z. Like
z-axis.
yeah, so is X. This like X, Y, Z.
It's supposed to that Z is supposed to be for 3-dimensional objects.
Okay, so let's
So this is just
let's
a 2-dimensional object.
But let's even change. Let's
Yes.
change the value of Z itself to see how it enlarge or contrast or whatever. Let's see that one too. I want to return back. We'll still get back to this. Let's change this last one to like 5 and see what happens. Okay. Saying it must be less than. It must be less than 2. I'm coming. Let's put 2 here. Okay. This works, but I'm trying to track the difference. I'm coming. Let me see if I'm able to trace the difference.
No, this was 7 and 3, so it's not. Yes.
This was the original one, right?
Yes.
So let's see if
I think we will not see any effects because it's supposed to work for 3-dimensional objects.
okay, thank you very much. So we are going back to this. This is